school. So now they tell you what I've already told you, because I wanted to tell you early, because it's important. You take phrase, x is 2 and y is 13, fine. It's an ordered pair. And then you can plot these to your own heart's content. If somebody, gives you this one, pays you $1, you'll get $1 for ordered pair, you're going to find a whole bunch. Here's the next level. Here's our equation. One equation, two unknowns. It doesn't have a unique solution. It has an infinite number of solutions. How do you find them? We've been there and we're doing it right here, yes? Now, what is special about these right here? Any of these, pick an ordered pair. It makes the equation true, yes or no. That makes sense? So this is a picture, are you with me, of the solution set. Yes, it's a picture. Now, it's just an extension into 2 dimensions of where we've already been. It is to say, let's say we have an equation, and I'm just going to put it equal. We'll just go ahead and solve one for fun. 3x minus 2 equals, 1 minus x minus 4. How about that? Okay. So we're going to go back to the past to make a point in the present. So let's see. What do we do first? We eliminate parentheses. So far, so good. Pick a side for x. I'm going to pick over here because I want my coefficient, the number times x, to be positive when I finish. So this one's got to go over here. Get all the x on one side, and then get this one over on the other side. Now, when I do that, what am I really doing? Do you agree if I say I'm getting similar terms on the same side so I can combine them? Isn't that really what I'm doing? So let's see. I've got 3x. Now I must admit, you probably, if you've done a bunch of these, probably wouldn't bother writing this step. So far, so good. Now, what do I mandate that other instructors and a lot of people don't? Picture. How come? Now you know. Okay. So we draw a picture. You roll for the marker. 7/4. There's our picture. We don't have an inequality. Remember, inequalities have a whole bunch of solutions usually. But they're all up there at the moment, they're all on the number line. Can I have an inequality where I take the equals and make it an inequality symbol? Yes. It's coming. Messier. Now the reason I did this is as follows. If I take this value and I put it here and calculate the left and the right hand side, what do you know about it? They're equal, yes or no? Is that what we're doing? We're getting a picture of what makes it true. Okay? So if I'm over here and I pick something here, if I pick, say, -7, and I put it into here and I put it into here, are those two numbers going to be equal? No. That's a picture of the solution set, and if it's not in the solution set, it doesn't make the equation true. With logical sense, that's where we've been. So they're going to ask the same question. If I have an ordered pair, does it make the equation true? Well, we already saw that this one did, because that's how we got the other coordinate, to make sure it works. And that one and that one. But what they're going to say here is, if somebody gives you another ordered pair, so let's have one. Then give me a nice number. 4. Faith, give me a nice number that's negative.
-2.
Does that satisfy the equation? If it does, that point's going to be on the straight line. If it doesn't, it's not going to be on the straight line, right? That's easy to see. Now notice what I'm going to do here, that a lot of times you don't see. I'm going to put a question mark here. Some people will just put equal and then they won't be equal. Well, I don't know. So here we go. 2 times 4 minus 3 times minus 2. I'm asking, is that equal to 6? Y'all on board with what I'm doing? Right? Now, what is that? 8 plus 6 is what? 14? Is 14 equal to 6? No, I've answered the question. Now, if I come over here and I plot 4, that was x, right there, and I go down minus 2, well, it's way down here because that was where there it is. That would be the ordered pair, yes or no? Is it on the graph? No. To be on the graph, it has to make the equation true. The picture has to match the analytical part. And the more you get into math for a while, the more pictures you're going to draw. They're just saying, here's something. Is it on the graph? It'll be on the graph if it makes this true. It won't be on the graph if it makes this false. And again, that's an